So this video introduces networking and communication systems. We want to understand the different categories and classifications of networks and understand encapsulation, Ethernet addressing, and be able to determine which network to use in a given application. First, we'll look at some different terminology, starting with protocols. So protocol is a set of rules or instructions or just a methodology used to effectively transfer information between two devices. So we see lots of different protocols when we're talking about any type of networking or communications between computers. A lot of times there's not just one protocol involved. A network is an interconnection of multiple devices for the purpose of transferring information or data between maybe just a few or many or every device on the network. A communication bus, often referred to as a network, is a protocol that includes the physical wiring methodology, possibly the voltage levels, addressing methods, things like that. A node, we're going to use the term node to reference some sort of device. That device could be our controller, it could be our PC, it could be a sensor, a smart sensor or actuator, something like that. Any device on the network that we want to communicate to. Okay, a server is a software program running on the computer. And this software program is specifically designed to basically respond to requests from a client. So a lot of times we think about a server as being a computer, usually like a big, powerful computer. But technically what makes it the server is the type of software that it's running so that it can handle requests from a client, which is just another software program. So you can have, any computer can be a server or a client, and they can actually be both at the exact same time. All right, so when we're sending messages, we can send that multiple different ways. One way is broadcast. So broadcast just means that you're sending the message out. You can kind of think about this as maybe being a radio station where you're sending out music or information, and you're just broadcasting it out on the airwaves, and you're hoping somebody is on the other end listening, but you have no idea whether they actually are listening or not. And then there's a multicast. Multicast is used like very common for gaming and stuff. So it's where you have a group of people who all want to share this information, and so you send it to all of this limited group. And then there's just an address, meaning like a single device or a single host that we want to send the message to. So we're sending it directly to them and no one else. So we're going to look at some different some different categories of networks. So we'll start with topology. All right. So here is some graphics of topologies to do communications. So the first one up here is point to point, right? And point to point is really, I guess, not quite a network because you're only talking to one other device. So you have this device A wants to talk to device B, and so you have some kind of mechanism set up to send the message directly to B from A. We also will see later on the term M to M, which means machine to machine, where it's kind of implied you got two dedicated machines. Like say you got two robots and they're just passing information between themselves and not concerned with what the rest of the world is doing. And then we have a bus. So I kind of mentioned a bus before, but this kind of shows a layout here where you have multiple devices all on the same network, and they can all send messages to whoever is on this network. But the wiring is basically just everybody's connected to the same wires. Then we have a star type connection. So the star type connection here, we have in the center something that is either called a hub or a switch. And the idea is that if A wants to send a message to B, then A can send that message. It sends it to the hub, and then the hub, if it's an actual hub, but the difference between a hub and a switch is if it's an actual hub, the hub would send the message to everybody, D, C, E, and B. But the message would have B's address, and so C, D, and E, they would get the message, but they would immediately ignore it because it's not to them. But they would actually receive it. Where what a switch will do is it will learn their what we call a physical address and say, so it'll say, well, this physical address is for B, so it will not bother C, D, and E by sending them a copy of the message. Only B would receive the message. Then there's a ring. So the problem with the hub is the fact that if the hub itself or the switch goes down in the star type network, then nobody can communicate. So another method was what they called the ring. And so the idea here is all the devices, it's kind of like a bus, but the difference is also with a bus, if something goes wrong with the wires, communication is lost. But the idea with a ring is that you have two paths for communications. So if A wants to send the message to B, it can send it clockwise through D, and then D would pass it on to E, and then on to B. Or to go if for some reason you couldn't do that way, or there's just too much traffic, it'd be faster, it could send it through C over to B. So it could go either way. So if the ring is broken somewhere, communication could still make it all the way around the ring. And to extend the ring, which is what we see a lot of modern systems are being set up as, is what we call mesh. And so with a mesh network, the idea is you have lots of nodes, and some of these are, their only job is to maybe kind of like the hub, to repeat the message, or to allow the message to be sent further on, or they could actually be devices that have other tasks that they're doing also. But the idea here is that you have multiple paths for the message to get to B. So A is trying to send a message. It can send it to either A could go to D, or it could go to C, or it could probably go to E, although I didn't draw a line for that one. But it could probably go to E directly. But it could also, from D, could send it over to E and then over to B. Or it could send it to C and then to F and then on to B. Okay, so there's multiple different paths for the message to get there. Okay. All right, so if we're looking at the most common networking available for, especially for standard business uses, is what we call Ethernet. So Ethernet is one of these protocols, and we'll look at some other details of it later. But the typical wiring for Ethernet is with what we call an Ethernet cable. Now, a cable just means that it has more than one conductor inside of the main insulation. And so the common types of connectors for Ethernet are, the low end is the Cat5e, and then there's an upper, the next step up is Cat6, and there's actually even some higher ones than that now, but either one of these, when you look at them, they're actually made up of 4 pairs of wires. So if you look over here, we have blue and blue-white, brown and brown-white, orange and orange-white, and green-white. And so these are pairs. So like one of these would be like a transmit. So say like the orange is going to transmit messages from A to B, and then the green is for B to transmit from B to transmit back to A. And so we have multiple wires so we can send communications back and forth simultaneously, kind of thing. So this is just a comparison chart showing Cat5e and Cat5.6 or Cat6, so that if you look at this, you can just see that Cat6 it basically has more twisting, and it has a separator in there, which just allows it to transmit the data at higher speeds. So at the end of these Ethernet cables is a RJ45 connector. Now the RJ it's an acronym for registered jack. And when you put in those 8 wires, those 4 pairs of colored wires in here, there's 2 ways defined for Ethernet connections to hook them up. And so we have a 568A or 568B. Now when you get a cable, you could get a cable that has the 568A on one side and the 568B on the other. So if you get that, that's called a crossover cable. If you get one that just has like B on both sides, that's called a straight through cable. Now I just mentioned earlier, I was talking about how you transmit. So let's say your A is going to transmit on 1 or 2. And so it transmits through the orange, and it goes through this straight through, and when it comes through, the data is coming over here into pins 1 and 2 at B. Well, the problem is that pins 1 and 2 are transmit ports, and so you really need the green for that. So this is important because you need to understand which type of cable to use depending on which connection you have. So let's go back to the topology here for a second. So if you look at, say, a point-to-point, if I just had a laptop and I wanted to plug it into a PLC or a robot to do some communications, and I just wanted to go straight to it, then I would have to use a crossover cable so that the transmit on pins 1 and 2 was sent to the receive pins at B. And then the B's transmit pins would be sent to A's receive pins. However, if we have a star kind of hookup with a switch or a hub in between here, then what the hub will do is it'll do the crossover for us. And so when you're hooking into a hub, which 99% of the time you do, you actually want a straight through, because you have a straight through from A to the hub and a straight through from the hub to a B, and the hub itself actually kind of handles the crossover of the transmit and receive wires. So like I say, it's important that you understand that. So if you do want to plug directly into, take your laptop and plug directly into another actual device and not a switch, then you need that crossover cable. All right, so a little bit more terminology here. We have a packet. The packet is what we call the encapsulated data. Okay, and so what does encapsulation mean? Well, encapsulation is talking about taking the data. So the data, I guess we need to mention the data. The data is what we want to actually send. Okay, so sometimes I'll call it data or information. And, so it's like I want to send this message to this other location. And so how do I get it there? All right. And so the way we get it there, I have this analogy at the bottom here with these pictures. Think of that I'm going to send a letter to the president. And so I'm going to, write this letter. The letter is my data, my information, my message that I want to send to the president and tell him, what I think, or invite him to my next party, or whatever, the message is. I want to send this to the president. And so when I do this, all right, I get the letter and I grab an envelope and I fold this up and I put it in the envelope. All right, so that's the encapsulation. I'm encapsulating the uh, the data, the letter, in the envelope. And then on the outside of the envelope, then, right, I have to put the address. So I put the president's address, West Wing of the White House on 1600 Pennsylvania Avenue. But I also put my return address, right, so that they know who it's from and where it's supposed to go back to in there. So when you have these packets of data and you're going to send them across the network, you always have the address of the person you're sending it to and the address of the actual sender yourself. Okay, and so here's the letter. Now, when the mail person comes to pick this letter up, right, they're going to put it in their mail bag. And then they're going to take it to a truck and put it in a truck. And so these are different layers of encapsulation. And you'll see as we go through here, you do this with you do this encapsulation of multiple times or at different layers. Okay, so just a couple of quick details here. I kind of referred to this on the previous slide. You can send data to one device and then wait for that device to send you data back. Okay, that's called simplex. So that's one-way communication. So I'm going to send it over and then I'm going to wait for it to come back. And that type of communication is used very often on buses, because most buses, since they're kind of sharing the same wires, especially if they only have two wires, only one can be communicating on that wire at a time. And so you kind of have to take turns. However, if you have a duplex setup, you can have communications going both ways simultaneously. Okay, and again, that I have like these boxes here showing what I kind of mentioned before. So the device on the left side, down at the bottom, we have the transmitter. It needs to be transmitting over to the receiver portion on the other device. And then the other device, when it's transmitting, it has to be transmitting back to the receiver side. All right, so back to this idea of encapsulation here. So with encapsulation, what we're doing is we're kind of have these different layers. So just like when we had our letter, and the letter went into the mail bag, and then the mail bag went into the mail truck to get sent out. And then, of course, obviously, when it gets to the other side, the bag will be taken out of the truck, and then eventually be delivered to the White House. So there's a couple of models of how many layers or the different types of layers that exist for communications. So down here at the very bottom, this is what we call the OSI model. And down at the bottom of this, there's 7 layers, and that's the physical layer. So that has to do with like the type of wire. If you're using copper wires and an Ethernet cable, or if you are using fiber optic communications, or maybe you're using radio signals, Wi-Fi, wireless type transmission, but whatever the media is. Now, at that physical level, there's one step above that in this OSI model is what we call the data link, which has that physical addressing that I mentioned that the switch deals with. Okay, so you have a data link, and it has an address at that level, and then so on your physical network, all the devices on that physical network, each one of them would have to have their own unique physical address. Then when we go up to the next layer, we have what we call the network layer, or sometimes they call it the IP, Internet Protocol layer, which we'll see on the next model. And those would also have some addressing. And then we have a transport layer, and then up at the top, in this model, they kind of break it into 3 different sections where they kind of call it application, but you notice they're all green because they're all very intertwined there. So let's look at the next model here. So this model is a little bit simpler. This is called the TCP/IP model, where TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol. And so in this model here, they take the application layer and they wrap all three of them from the OSI, or they just call it the application layer, and they're kind of done with it. And then we have the transport layer, and then we have the internet protocol or the network layer, and then we have the physical layer. So Ethernet is the physical layer in there, and the OSI model had it as like physical plus the data link. Okay, so a lot of times we talk about an Ethernet network and we kind of think about it as the IP address also, but technically the IP address is a separate layer. So let's kind of try to break out the differences here. All right, so when we're doing Ethernet, we refer to the packet, like if you think about the letter that I'm sending to the president, that's like the packet. So the packet has the address information in it, my information, and the president's information, so it gets delivered there properly. And it also then inside of that, it has the actual data that I want to send them. Okay, so when you send data across a network, especially Ethernet, although we tend to use this term for most networks, but now we call it a packet. That packet has the data, and then it has the host address and the sender address in there. So the data, the letter inside of the envelope, is referred to also as a payload. All right, so let's go back to this letter then. So we have, when you look at this letter and you look at the addressing, okay, there's multiple layers of addressing. So this kind of, shows the multiple layers of that OSI or the TCP/IP layer that models that we just looked at. So here we have say, well, let's take my address here at 6200 Frank Avenue, right, North Canton. Right, so this here, we kind of have the city, North Canton, Ohio, and then we have the street, Frank Avenue, and then on Frank Avenue we have the the building number 6200. So if you think about the whole model with, say, like that whole bag, the mail bag, and then the truck, right? So like all the trucks at the post office, they all have their numbers, so you know which one, and say, okay, here's the truck that's going to Canton, Ohio, or here's the truck that's going to Washington, D.C., or it might be going directly to Washington, D.C. It might go to Columbus first and then gets put in a different truck. But so you can kind of think of maybe like the city, let's say the state. So you can think about, say, the state, like either Ohio or, Washington, D.C. I know it's technically not a state, but, you can think about D.C. as being the truck. And then you could think about the mailbag in the truck as, say, being the city piece. And then you can think about the just the street address here. When you look at the street address, again, there's the street itself, and then there is the building number or house number. If you think about your own house or whatever, you call it a house number, but in this case it's a building, or a collection of buildings. But 6200, right, is, so on Frank Avenue there's only one building with the number 6200. Okay, and then once it gets inside of Stark State, right, now it needs actually delivered to where I'm at. So then I have the engineering division here showing you, okay, well, this is this goes to the B building. I mean, I could put B215, the office number there or whatever, but putting engineering division, they'll know where the engineering faculty offices are and get it to my office area. And then once it gets to my office area, right, then someone will sort through all the mail that came in that day and say, oh, well, this is Hartman's, and then they'll put it in my little box there so that I can get that letter back, well, after the president replies and, invites me to, the next big shindig they're having at the White House. Okay. So these are kind of these analogies here. Okay. So I just kind of went through them on the other slide here. So this slide is just kind of putting them in text and stuff. But again, you want to kind of think of all these different layers and the different pieces here, right? So like here's the letter, but the letter goes into a mailbox or a mail bag, and then the mail bag goes into a mail truck. All right. And so you kind of start up here at the application where you create your data, and then you transport that down through these different layers until it gets to the device where you want it to get to, and then it comes back up through those different layers for the receiver or the person on the other end to actually be able to read the letter at that point. Okay, so this MAC address, also known as the physical address or hardware address, is on layer 2 of the OSI model, or layer 1 of the TCP/IP model. And then there's the network layer, which is layer 3 of the OSI model, which is the IP address. And then there's a port number. So the port number is on that transport layer. Okay, and so for us, now we've already kind of seen this in class when we tried to connect to our BeagleBone. Okay, when we tried to connect to the BeagleBone, we put in like 192.168.7.2. That was the IP address, which was up here at layer 3. But then we wanted to get to node red. And so for node red, then we had to put in a colon 1880. So that colon 1880, that's what gets us to node red, that application. So that's kind of at the application layer. It's basically, I mean, technically it's a transport layer, so it's like almost underneath of the application layer, but it's the part that basically links you between just the computer itself and the software. So you go to that port number to get that data. Now, along with inside of our packet, along with the actual message, we also send what's called a checksum. And the idea of the checksum, right, remember that our data is all a bunch of ones and zeros. So we basically like add up how many ones we have, how many zeros we have, and put that in the packet. And then when we send the packet, and when it gets on the other end, one of the things that's done is it checks this checksum to make sure that it matches the count so that no data was lost as it was being transmitted through. Okay, so now the checksum is a little more complicated than just adding up the ones and zeros, okay, but just give you a basic idea of what the purpose of that is for. All right. And then there's also what we call the preamble. Now, the preamble kind of has to deal with timing, okay? So if you think about, every day, let's say like if you wanted to send something FedEx to California or Hawaii or something. So you would, put it, package this thing up that you're going to send, and put it in the FedEx truck, or drop it off at the FedEx place. They'll put it in the truck, and that truck then will take it to an airport, and then that airport will put it on a plane and they'll fly it to like Tennessee. Tennessee's like one of the FedEx's big sorting places. So all the planes come in to Tennessee, and then they all have to be like supposed to be down there by say midnight, and then they unload the planes and they run them all through and they sort all these packages, thousands and thousands of packages, and they sort them all up and then put them back on the planes. So you have like our plane like leaving from Canton, Ohio, is going down to Tennessee with packages that are going all over the world. Some of them are going to California, some of them are going to Florida, some of them are going to England, and so they sort them all out and then put them on the planes that are going to take them closer to their final destination. And then all the packages from Canton are put back on the Canton plane. All the ones that are coming from all over the world are sorted and then all put on the Canton plane to bring them back into Canton to have Canton sort them. Okay. And so the point here is the timing piece, right? If you want your package delivered, you need to make sure it's on the truck, on the plane, and gets to Tennessee by midnight so it can do all this sorting so that it can be then and get on that plane out to California or wherever it is that it was going before like I say, the plane from Canton needs to be down there before midnight, or our package will be delayed an entire day. Okay. All right. So the MAC address, or this hardware address, again, this is for Ethernet. Okay. We'll look later on when we look at different networks, we'll look at different address schemes. But for Ethernet, that's that physical layer. It has a 48-bit address, and every device on this physical layer must have a unique 48-bit address, right? You can't have like two devices on the same network with the same address. Then there's the IP address. Okay, now the IP address has two parts, and so we'll look at this here in a little bit more coming up, but has two parts. It has the street and then the building number, 6200 Frank Avenue. Well, the IP address has what we call a network piece, which is equivalent to the street, and then a host number, which is equivalent to the building number on that street. So you have a network, and on this particular network you can have maybe 500 computers, or maybe only 254 computers, and we'll look at that later. Or maybe you got 1,000 computers on this network, and on this network each of them has to have a unique host name. Okay, so the host name is equivalent to like the building number, like 6200 is Stark State's building number on Frank Avenue. But the IP address is kind of flipped. So the host number is on the right-hand side and the street number is on the left-hand side. So they're kind of flipped from a street address like this. Okay. And then we have the port. So I already kind of discussed the port, right? So you had your IP address for us, for our BeagleBone was 192.168.7.2. That was the BeagleBone. But then the port number was that :1880. Well, the number is the 1880. The colon's just a separator, right? But the 1880 after the colon gives us the port that got us into Node Red, as opposed to some other service or server program running on that BeagleBone, which there are actually several. Okay, now to send the data out, okay, once we want to get out of our current network, we have to go through what's called a gateway or a router. So you see the terms gateway and router. They're two different terms that deal with saying that, okay, again, this is kind of the idea of the mail truck. You get the package on the mail truck, and then the mail truck then, gets out on the highway and gets out on 77 and goes to Columbus or whatever, where they're going to take our letter on down, and then it'll be sorted again, put on another truck headed toward Washington D.C. kind of deal. So and there's probably another stop along the way before it actually made it to Washington D.C. But the gateway is that device that allows it to get from our local network out to out on the roads, moving out to the internet and going from network to network until it reaches its final destination. So you have, again, there's two terms here, router or gateway. There's a slight difference between their actual meaning, but for the most part for us, for this class, either one of these terms is basically just saying this is our path to get off our current network onto another network. All right, so I'm going to stop right here for this video and start